And now that you have inserted some documents into your MongoDB collections, I want to take a moment to talk about that underscore ID property in the context of MongoDB, because it's a little different than the IDs that you're probably used to if you've used other database systems like Postgres or MySQL. To kick off our discussion of the ID property, let's go ahead and rerun the MongoDB connect file. This is going to insert a new document into the user's collection like we've defined right here. I'm going to go ahead and do that by running the file through node. It's in the playground folder, and the file itself is called mongodb-connect.js. I'm going to run the command, and we're going to print out the document that got inserted. And as we've seen in the past, we get our three attributes as well as the one added by Mongo. Now, the first thing you'll notice about this is that it is not an auto-incrementing integer, kind of like it is for Postgres or MySQL, where the first record has an ID of 1 and the second one has an ID of 2. Mongo does not use this approach. Mongo was designed to scale out really easily. Scaling out means that you add on more database servers to handle that extra load. Imagine you have a web app that gets about 200 users a day, and your current servers are ready for that traffic. Then you get picked up by some news outlet and 10,000 people flood your site. With MongoDB, it is really easy to kick up new database servers to handle that extra load. When we use a randomly generated ID like this one, we don't need to constantly communicate with the other database servers to check what the highest incrementing value is. Is it 7? Is it 17? It doesn't really matter. We're simply going to generate a new random object ID and use that for the document's unique identifier. Now, the object ID itself is made up of a few different things. It's a 12-byte value. The first 4 bytes are a timestamp. We'll talk about that in just a second. That means that built into the data right here, we have a timestamp that refers to the moment in time the ID was created. This means in our documents, we don't need to have a created at field. It's already encoded in the ID. The next 3 bytes, those are a machine identifier. That means if 2 computers generate object IDs, their machine ID is going to be different. This is going to ensure that the ID is unique. Next up, we have 2 bytes, the process ID, just another way to create a unique identifier. Last up, we have a 3-byte counter. This is similar to what MySQL would do. This is only 3 bytes of the ID. As we talked about, we have a timestamp, which is going to be unique, a machine identifier, a process ID, and lastly, just a random value. That is what makes up the object ID you see right here. Well, the object ID is the default value for underscore ID. If nothing is provided, you can indeed do whatever you like with that property. For example, over inside of the MongoDB connect file, I can specify an ID property right here. I'm going to give it a value. Let's go with 1, 2, 3. Add a comma at the end, and that is perfectly legal. We can save the file, rerun the script using the up arrow key and the enter key, and what do we get? We get our record where the underscore ID property is 123. The object ID is the default way MongoDB creates IDs, but you can do anything you like for ID creation. Over inside of RoboMongo, we can give our users collection a refresh. And what do we get? We get our documents. We have the one we created in the last video and the 2 we just made now, all with a unique identifier. And this is why unique IDs are really important. In this example, we have 3 properties, name, age, and location, and they're the same for all the records. And that's a reasonable thing to do. Imagine 2 people need to do the same thing, like buy groceries. That string alone is not going to be enough to uniquely identify a to-do. Object IDs, on the other hand, are going to be unique, and that is what we're going to use to associate things like to-dos with things like users. Next up, I want to take a look at some things we can do with the ID inside of our code. As I mentioned earlier, a timestamp is embedded inside of here, and we can actually pull that out. Over inside of Atom, what we're going to do is remove the ID property right here. The timestamp is only going to be available when you're using object IDs. Then, down below, inside of our callback, we can go ahead and print the timestamp to the screen. If you remember, result.ops is an array of all the documents that got inserted. We're only inserting 1 here, so I'm going to access the first item in the array. Then we're going to access the ID property. This is going to do exactly what you might think. If we save the file and rerun the script over from the terminal, all we get is the object ID printing to the screen. And now, though, we can call a method on the underscore ID property. What we're going to call is .getTimestamp. A get timestamp is a function, but it doesn't take any arguments. It simply returns the timestamp that the object ID was created at. Now, if we go ahead and rerun our program, what do we get? We get a timestamp. Right here, I can see that the object ID was created on August 11th, 2016 at 15:03 in GMT, which would be 11:03 on the East Coast where I am, so this timestamp is indeed correct. This is a fantastic way to figure out exactly when a document was created. Now, we don't have to rely on MongoDB to create our object IDs. Inside of the MongoDB library, they actually give us a function we can run to make an object ID whenever we like. For the moment, let's go ahead and comment out our call to insert one right here. Up above, at the very top of the file, we're going to change our import statement to load in something new off of MongoDB. And we're going to do this using an ES6 feature known as object destructuring. Let's take a quick second to talk about that before we actually go ahead and use it. Object destructuring lets you pull out properties from an object, creating variables. This means if we have an object called user and it's set equal to an object with a name property set to Andrew and an age property set to 25, we can easily pull out one of these into a variable. Let's say, for example, we want to grab name and create a name variable. To do that, using object destructuring in ES6, we're going to make a variable, then we're going to wrap it inside of curly braces. We're going to provide the name we want to pull out. This is also going to be the variable name. Then we're going to set it equal to whatever object we want to destructure. In this case, that is the user object. And there we go. We have successfully destructured the user object, pulling off the name property, creating a new name variable, and setting it equal to whatever the value is. This means right below, I can use console.log to print name to the screen. I'm going to rerun the script, and we get Andrew right here, which is exactly what you'd expect because that is the value of the name property. ES6 destructuring is a fantastic way to make new variables from an object's properties. I'm going to go ahead and delete this example. And up above, we're going to change our require statement to use destructuring. Before we add anything new, let's go ahead and take this statement and switch it to destructuring. Then we'll worry about grabbing that new thing that's going to let us make object IDs. I'm going to copy and paste this line down below and comment out the old one so we have it for reference. What we're going to do is remove our .mongo client call after require. There's no need to pull off that attribute like we do here because we're going to be using destructuring instead. That means over here, we can use destructuring, which requires us to add our curly braces, and we can pull off any property from the MongoDB library. In this case, the only property we had was Mongo client. This creates a variable called Mongo client, like we do here, setting it equal to the Mongo client property of require MongoDB, which is exactly what we did here. This code is identical to the code up above. Now that we have some destructuring in place, we can easily pull more things off of MongoDB. We can add a comma right here and specify something else we want to pull off. In this case, we're going to pull off uppercase O, object, uppercase ID. This object ID constructor function lets us make new object IDs on the fly. We can do anything we like with them. Even if we're not using MongoDB as our database, there is some value in creating and using object IDs to uniquely identify things. Down below, we can make a new object ID by first creating a variable. I'll call it OBJ, and we'll set it equal to new object ID, calling it as a function just like this. Using the new keyword, we create a new instance of object ID. Next up, we can go ahead and log that to the screen using console.log obj, just like we did earlier. And this is a regular object ID. If we rerun the file over from the terminal, we get exactly what you'd expect. We get an object ID looking thing. If I rerun it again, what do we get? We get a new one. They are both unique. Using this technique, we can incorporate object IDs anywhere we like. We could even generate our own, setting them as the _ID property for our documents, though I find it much easier to let MongoDB handle that heavy lifting for us. I'm going to go ahead and remove the 2 lines right here since we won't actually be using this code in the script down below. And with this in place, we are now done. We have learned a bit about object IDs, what they are, and why they're useful. In the next couple videos, we're going to be taking a look at other ways we can work with MongoDB. We'll learn how to read, remove, and update our documents. It's all coming up next, so stay tuned. I will see you next time.